Hello, in this video we are going to discuss PNP and NPN current mirrors. We are already used to the NPN current mirrors in previous videos. You can check them up and they look something like this. So we said if you had a reference current from a band gap circuit and you fed that into a diode connected device, and this diode connected device was made from a PNPN transistor, so we call that NPN diode connected device. Then a voltage will be generated between the base and the emitter, and this could be used to bias another NPN transistor. So this is how you create a current source from an NPN transistor. But what if the current source you want is a p-type current source, like over here Q2? So this is a p-type current source because it's taking some current from the VCC and drawing it into a node. In this case, the node will be this particular node here. So what would happen if I connected this node X1 directly to Q2? What we expect is the voltage base emitter of this Q reference 1, which is the NPN diode connected device, to be in the range around the vicinity of 0.7. Now, assuming the VCC is 5 volts, then the base to the ground, or the base voltage of 0.7, if we connected that here, that means the PNP device Q2 is going to have a emitter base voltage of 5 volts minus 0.7, which is going to be something like 4.3. And if I calculated a current, I would get over 26 millivolts. I'm going to get something around 10 raised to the power 57 amperes. So that should tell us this: we cannot connect this kind of setup to an NPN, to a PNP device. So what we could do is we could get a PNP reference, and that goes like this. You have a PNP diode connected device, so this should be my VCC, and my PNP device is here. So this is my emitter, and diode connected device, I connect the base to the collector, and this time my reference from the band gap circuit should be N-type. So previously I had a P-type. By P-type I mean something that is taking the current from the VCC into a node. Then I had N-type diode connected device. At this time it's the other way around. I have a P-type diode connected device and an N-type band gap reference current. Alright, so what happens is that, assuming we have 5 volts as a VCC, then I'm expecting the base emitter voltage to be something like 0.7. then obviously the base voltage should be something around 4.3, and that would make sense for me to connect that directly to another PNP device, which is diode connected, and I'm expected to get the current similar. So I copy is expected to be equal to I ref here. But there's a problem. I can only build one band gap circuit or reference current in my circuit or on my chip, and I require different current sources, p-type current sources and n-type current sources on the same chip. So if I have any of them available, then I should be able to go through this to do the conversion. So let's quickly look at this diagram here, what is happening. So in this diagram, what I do have is an n-type current mirror, which can only be connected to n-type or NPN current sources or n-type current sources. But I want to bias this current source Q2 with that, so I cannot connect it directly. So I need an NPN device here as in Q1, and I'm allowed to connect this to Q1 because an NPN current device, NPN current source. So we know the voltage here is around 0.7 depending on the reference current I'm feeding it, and this is allowed. So ICM here is going to be almost equal to I reference here. So I can see ICM, this whole setup, as a new current source, and if I were to draw it like this, then this part of the setup looks like a new current source which is feeding from a node to the ground. So I'm permitted to put a PNP on top of it, it connects to VCC just as is here. So this becomes QREF2, and then I'm allowed to connect this to my PNP device. So this is important to understand, and it helps us to intuitively read circuits. So the more we understand these fragments of circuits, the more easily we are to understand complex circuits when we see them. So this is a nice video. Take your time, make sure you understand everything here. Thank you.